Hello, welcome to students, our YouTube channel, Maths Balakrishna sir, grade 10, chapter 2, polynomials, NCERT syllabus. In last video, I am explaining some examples. Now, example 9. Find a quadratic polynomial whose zeros are 1 and minus 3. Verify the relationship between the coefficients and 0 of the polynomial. Okay, here, let us take alpha, beta are zeros of quadratic polynomial ax square plus bx plus c. So in the problem they given that their zeros what are there 1 and minus 3, that is alpha is equal to 1, beta is equal to minus 3. Okay, here we know that the zero of the quadratic polynomial is x square minus of alpha plus beta into x plus alpha beta. Okay, so that is here. First find that sum of the zeros. So sum of zeros alpha plus beta is equal 1 plus minus 3 plus into minus 1 minus 3, that is minus 2. Okay, next product of zeros alpha into beta is equal 1 into minus 3 plus into minus, that is 1 3 ja 3, alpha into beta is minus 3. Sum of the zeros alpha plus beta is minus 2, alpha into beta is minus 3. So here we know that zeros of quadratic polynomial is k of x square minus alpha plus beta into x plus alpha beta. So here k is the constant, the k value take that 1, so that is here x square minus alpha plus beta is minus 2x plus alpha into beta minus 3. Minus into minus of means into minus plus, so that is here x square plus 2x plus into minus. So this is the our required quadratic polynomial is x square plus 2x minus 3. This is the zeros of the quadratic polynomial. The given zeros are 1 and minus 3. So for the given the zeros 1 and minus 3, the quadratic polynomial is x square plus 2x minus 3. Exercise 2a. Find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the quotients. So here the first problem, first one, x square plus 3x minus 10. So first p of x, let us take p of x. P of x means what? Polynomial with variable x. So p of x is equal to x square plus 3x minus 10. For this polynomial, first find the factors. How you can find it is a quadratic polynomial? Okay, for this quadratic polynomial you can find the factors by using factorization theorem. Okay, how? Here x square quotient is 1, constant is 10. Okay, 1 into minus 10. 1 into minus 10, that is equal to minus 10. What are the factors? 1 10 ja, 5 2 ja, 2 5 ja, 10 1 ja. Here x quotient is how much? 3. Here when you take any two factors, their sum or subtraction is become x quotient. Okay, here x quotient is how much? Plus 3. Which factors we take? We can get plus 3. That is 5 minus 2. 5 minus 2 is how much? 3. So when you product 5 into minus 2, we can get how much? Minus 10. Which factors we take? Their product we can get minus 10 and their difference is become plus 3. That is 5 minus 2, that is 3. Next 5 into minus 2 minus 10. So that is here x square plus 5x minus 2x, 10 we can write as 5 2 ja. So from the first two terms what the common? X of x plus 5. From last two terms what the common? Minus 2. When you take the minus is taken outside, in the place of minus there is minus into plus. Okay, minus we can write as product, that is minus into plus. So minus taking outside, what the remaining here? Plus, that is here x plus 5. Okay, so in this total what the common? X plus 5. X plus 5 of x minus 2. So the factors of the given quadratic polynomial is x plus 5 into x minus 2. These two are factors of this quadratic polynomial. So now find the factors, find the zeros. That is here, let us take p of x is equal to 0, x plus 5 into x minus 2 is equal to 0. The product of two polynomials is 0. Either first one is 0 or second one is 0. So that is here x plus 5 is equal 0, x minus 2 is equal 0, or both polynomials are 0. So plus 5 is going to happen minus 5, minus 2 is going to happen plus 2. So here therefore minus 5, 2 are zeros of the quadratic polynomial x square plus 3x minus 10. So let us take alpha is equal minus 5, beta is equal 2. Here what the question? Find the 0 of the following quadratic polynomial and verify the relationship between zeros and quotients. So first we can find the zeros. Next we can check the relationship between zeros and coefficients. So sum of zeros is alpha plus beta, that is minus 5 plus 2, that is minus 3. Next product of zeros, alpha into beta, minus 5 into 2, that is minus into plus, minus 5 to 10. So the given quadratic polynomial we can comparison with ax square plus bx plus c. When comparison these two polynomial, then a is equal to 1, b is equal to 3, c is equal to minus 10. So here we know that the relation between zeros and quotients, the sum of the zeros is equal to minus b by a minus quotient of x by quotient of x square. Next product of zeros alpha into beta is equal to c by a, constant by quotient of x square. So here alpha plus beta is equal to minus b by a, that is here minus 3 by 1, that is equal to minus 3. Next alpha into beta is c by a, that is minus 10 by 1, that is equal to minus 10. So this is the relationship between zeros and coefficients of a given quadratic polynomial. Next x square plus 7x plus 12. So here p of x is equal to x square plus 7x plus 12. First find the factors of this polynomial. So here x quotient is 1, constant is 12, 1 into 12, 12. So what are the factors of 12? 1 12 ja, 2 6 ja, 3 4 ja, 4 3 ja, 6 2 ja, 12 1 ja. In these factors of 12, we take any two factors, their sum or subtraction is become x quotient. Here which factors we take, their sum is become x quotient 7. Okay, that is here 3 plus 4 or 4 plus 3. How much? 7. 3 4 ja 12, 4 3 ja 12. So when you adding these two, we can get how much? 7. When you multiply these two, we can get how much? 12. Okay, so here x square plus 3x plus 4x plus 12 we can add as 4 3 ja. So in this two what are the common? X of x plus 3. In this two what are the common? 4 of x plus 3. Total what are the common? X plus 3 of x plus 4. So p of x, these two are factors of the given quadratic polynomial. So here now find the zeros. Let us take p of x polynomial is equal to 0, that is x plus 3 into x plus 4 is equal to 0. The product of two polynomials is 0, either first one is 0 or second one is 0 or both are zeros. That is here x plus 3 is equal to 0, x plus 4 is equal to 0, x is equal to minus 3, x is equal to minus 4. Okay, plus 3 is going to happen minus, plus 4 is going to happen minus. So now minus 3 minus 4 are zeros of x square plus 7x plus 12. Okay, next let us take alpha is equal to minus 3, beta is equal to minus 4. So sum of zeros, alpha plus beta is equal to minus 3 plus minus 4 plus c into minus 3 minus 4 minus 7. So next product of zeros, alpha into beta is equal to minus 3 into minus 4 minus plus 3 4 ja 12. So this is the sum of zeros is minus 7, product of zeros is 12. So here the polynomial, the given quadratic polynomial, we can comparison with the general form of quadratic polynomial. So here x square plus 7x plus 12, we can comparison with ax square plus bx plus c. Then when you comparison, then a is equal to 1, b is equal to 7, c is equal to 12. So Sum of the zeros. What is the relation between the zeros and quotient? The sum of the zeros is equal to minus b by a. Product of zeros is c by a. Minus b by a means minus quotient of x by quotient of x square. C by a constant by quotient of x square. So alpha plus beta is equal to minus b by a. That is minus 7 by 1, that is equal to minus 7. Next alpha into beta is c by a. So that is 12 by 1 is equal to 12. Okay, this is the relation between zeros and quotients of a given quadratic polynomial. Next, 2x square minus x minus 6. Here, p of x, polynomial with variable x, 2x square minus x minus 6. This polynomial we can find the, first find the factors, after that we can find the zeros. Here, x square quotient is how much? 2, constant is how much? Minus 6. So 2 into minus 6, that is equal to minus 12. So what are the factors of 12? 1 12 ja, 2 6 ja, 3 4 ja, 4 3 ja, 6 2 ja, 12 1 ja. In these factors we take any two factors, their sum or subtraction is become x quotient. Here there is no x quotient. What is the x quotient? 1. 1 is multiplied with anything, we get the same. So 2x square minus 1x minus 6. Here minus 1 means which factors we take, we can get the minus 1, that is plus 3 minus 4, that is equal minus 1, and we can product plus 3 and minus 4, we can get minus 12. Plus into minus, minus 3 4 ja 12. So here 2x square, in the place of minus 1 we can write as plus 3x minus 4x, 6 we can write as 2 3 ja. So in this two what are the common? X, 2x plus 3. Here what are the common? Minus 2, 4 you can add as 2 2 ja. Okay, minus how you can write? Product minus into plus. When you take the minus is taking outside, what the remaining? Plus. So minus 2 is taking outside, what the remaining here? X plus 2x plus 3. Total what the common? 2x plus 3 is common of x minus 2. So p of x is equal 2x plus 3 of x minus 2. So here let us take p of x is equal 0, 2x plus 3 into x minus 2 is equal 0. So the product of two polynomials is 0, either first one is 0 or second one 0 or both zeros. That is here 2x plus 3 is equal 0, x minus 2 is equal 0. Plus 3 is going to happen minus 3. Okay, x is equal minus 3 by 2, minus 2 2. So here x is equal to minus 3 by 2, 2 or zeros of 2x square minus x minus 6. Let us take alpha is equal minus 3 by 2, beta is equal 2. So sum of the zeros, alpha plus beta is equal minus 3 by 2 plus 2. So here 2 you can write as 2 by 1. So here minus 3, 2 2 ja 4 by 2, minus 3 plus 4 1 by 2, alpha plus beta is equal 1 by 2. Next product alpha into beta is here minus 3 by 2 into 2, here 2 2 cancel, that is minus 3. Okay, so the polynomial we can comparison with ax square plus bx plus c. So here 2x square minus x minus 6 we can comparison with ax square plus bx plus c. When comparison, a is equal to, b is equal to minus 1, c is equal to minus 6. So alpha plus beta is equal minus b by a. Here minus of minus 1 by a is 2. So that is your minus minus plus 1 by 2. Next alpha into beta is c by a. So c is minus 6 by 2. Okay, minus 6 by 2, 2 1 ja, 2 3 ja, that is minus 3. So product of zeros is minus 3. This is the relation between zeros and coefficients of a quadratic polynomial. Next 2 root 3 x square minus 5x plus root 3. So here p of x is equal to 2 root 3 x square minus 5x plus root 3. Here x square quotient is how much? 2 root 3. Constant is how much? Root 3. So here that is 2 root 3 into root 3. Okay, 2 into root 3 into root 3 whole square. Square root cancel, 2 3 ja 6. Now the factors of 6 are here 1 6 ja, 2 3 ja, 3 2 ja, 6 1 ja. In these factors we take any two factor, their sum or subtraction is become x quotient. Okay, here we take that 1 minus 6, we can get minus 5. But when you product, we can get as plus 6. 1 into minus 6, how much? Minus 6. But here we want plus 6. So that's why we take as minus 2 minus 3. Okay, minus 2 minus 3, nothing but how much? Minus 5. Minus 2 into minus 3, minus minus plus 2 3 ja 6. So here 2 root 3 x square minus 2x minus 3x plus root 3. Here in this 2 what are the common? 2 root 3, 2 into root 3, x square means x into x, 2x means 2 into x into 1. Here 3 we can write as root 3 whole square, square root cancel, we can get as 3. So root 3 whole square x plus root 3 into 1. Here the plus we can write as minus into minus. So now here what is the common? 2x, 2x. 2x is taking outside, what the remaining? Root 3x minus 1. Here root 3 whole square means root 3 into root 3. So here root 3 is taking outside, what the remaining? Root 3x minus 1. Here minus and minus plus. Okay, here in the plus we can take the minus is taking outside, what the remaining? Minus. Here root 3 whole square means what? Root 3 into root 3. So that is here root 3x minus 1 into 2x minus root 3. So here p of x, let us take p of x is equal to 0. Root 3x minus 1 into 2x minus root 3 is equal to 0. Here the product of two polynomials is 0. Either first one is 0 or second one 0 or both are zeros. So root 3x minus 1 is equal to 0. 2x minus root 3 is equal to 0. So root 3x minus 1 is going to start up in plus. So x is equal to 1 by root 3. Next 2x is equal to root 3. X is equal to root 3 by 2. Okay, these two are zeros of the given quadratic polynomial. So therefore 1 by root 3 by 2 are zeros of 2 root 3 x square minus 5x plus root 3. So here sum of zeros alpha plus beta is equal 1 by root 3 plus root 3 by 2. So 1 into 2, 2, root 3 into root 3 whole square by 2 root 3. Square root cancel, that is 2 plus 3 by 2 root 3. 2 plus 3, 5 by 2 root 3. So next product of zeros. Product of zeros. Alpha into beta is 1 by root 3 into root 3 by 2. Here root 3 cancel, that is 1 by 2. So here the polynomial you can comparison with ax square plus bx plus c. Here 2 root 3 x square minus 5x plus root 3. We can comparison with ax square plus bx plus c. So when comparison here, then a is equal to 2 root 3, b is equal to minus 5, c is equal to root 3. So here the relation between zeros and quotients alpha plus beta is minus b by a. Here b is minus 5 minus of minus 5 by 2 root 3. So minus minus plus 5 by 2 root 3 alpha plus beta. Next alpha into beta is c by a, that is root 3 by 2 root 3. Root 3 cancel, that is 1 by 2. So alpha into beta is equal to 1 by 2. This is the relation between zeros and quotients of a given quadratic polynomial. So next 8x square minus 4. Here p of x is equal to 8x square minus 4. So here 8x square, how we can write? 8 4 2 ja, 4 4 1 ja, 4 is taking outside, we can get as 2x square minus 1. So that is here 4 of here 2x square minus 1, we can write as root 2 whole square x square minus 1 square. So square root cancel 2, that is 4 of root 2x whole square minus 1 square. Now it in the form of here a square minus b square, that is a plus b into a minus b, that is 4 of root 2x plus 1 into root 2x minus 1. So let us take p of x is equal to 0, that is 4 of root 2x plus 1 into root 2x minus 1 is equal to 0. So here 4 multiple is going to set up and divide. So root 2x plus 1 is equal to 0, root 2x minus 1 is equal to 0, root 2x minus 1, x is equal to minus 1 by root 2, root 2x is equal to 1, x is equal to 1 by root 2. Okay, here therefore minus 1 by root 2, 1 by root 2 are zeros of 8x square minus 4. So sum of zeros alpha plus beta is minus 1 by root 2 plus 1 by root 2. So here minus 1 plus 1 by root 2, these two are like fractions, write the common denominator. So minus 1 plus 1, that is 0 by root 2, 0 by anything 0. Next alpha into beta, that is 1 by root 2 into 1 by root 2. Minus 1 into 1, minus 1, root 2 into root 2 whole square, square root cancel, that is minus 1 by 2. So the polynomial you can comparison with ax square plus bx plus c. So here 8x square minus 4 you can comparison with ax square plus bx plus c. But in the given quadratic polynomial there is no x quotient. So here we can write as 8x square plus 0x minus 4. When you comparison, a is equal 8, b is equal 0, c is equal 4. So alpha plus beta is minus b by a, that is 0 minus 0 by 8, 0 by anything 0. Next alpha into beta is c by a, that is 4 by 8. So 4 1 ja, 4 2 ja, that is 1 by 2. So this is the relation between zeros and quotients of a quadratic polynomial. Friends, if you like the video, subscribe my channel and share your friends.